Hi, my name is Connie Lyons, and today we're going to be factoring polynomials. And our sample problem is going to have a mixture of a lot of factoring. And we're going to be going over the general strategy first. Okay, the general strategy, the first thing is look for a common factor. Okay, we're putting 3 on the outside because it divides by 3. Our 3 terms is after we've divided by 3. There was no x in common. Okay, the next thing, after we look for a common factor, we check to see how many terms there are. 1, 2, 3. There are 3 terms. Our first term here, it cannot be simply unfoiled. Our first term is not a perfect square. In a trinomial square, your first and your last term have to be perfect squares, but that's not all. Also, the last term has to be positive. This one has the minus here. This is not a trinomial square. It won't be able to be factored the way these can. So this one is prime. Okay, now let's go to the first problem. 9x squared minus 30x plus 25. Okay. 9x squared will be 3x times 3x. 25 is 5 times 5. Our outer and inner should give us the 30. The outer is 15, the inner is 15. That gives us 30. We need negative 30. This is going to tell us what sign to put in both places. So they'll both be minus, negatives. So we'll have negatives both places. This is why it's called a trinomial square. It has, this term is twice it is squared. All of these I've done for you. We'll just go over them really quick. X squared is x times x. 25 is 5 times 5. If you had the outer and inner, you would have 5 and 5. We need a positive 10, so we had the positive 5 there. This is almost the exact same problem as this, except the middle term, instead of being positive, is negative, so that changes our middle sign to negative. And this one here, 4x squared is 2x times 2x, 9 is 3 times 3, 2 times 3 gives us 6. We would have had outer and inner. 6 and 6 is 12. Negative, we have to put the negative there. Now let's go back to our sample problem. The first and last terms are supposed to be perfect squares. They are not. Also, that's not a positive. So this is not a trinomial square. The next thing we were supposed to do was check for the AC method. But the AC method involves grouping, so we're going to jump to the grouping. If there's 4 terms, you group. Here's our grouping. Okay, we have these 2 terms grouped, these 2 terms grouped. What do these have in common? 5x squared plus 15x have 5 and an x in common. Here we need 2 terms because we're looking at 2 terms here. So we need the x plus 5x times 1 is 15x. We need the 3. These will always be the same here and here. So we'll put x plus 3 over here. And all we need now is what we're going to put there. How are we going to get ax if we have an x? We need an a out there. That needs to be positive. Now let's check to make sure it works. Ax is our first term. A times 3 is 3a. So that works. Okay, now what do we have in common? We have x plus 3 in common. The other term will be, the other factor, I'm sorry, will be 5x plus a. And that is as far as that can go. So that's the factor of this. There's not 4 terms here. So we're not going to group yet. We need to go to the AC method and see if we can use it. Now let's go to this one. I already have the factors written out to save time. 6 times 15 is 90. So I've written here all the factors of 90. We need the ones that will subtract to give us 1. That would be 9 and 10. 6x squared plus 9x have 3 and an x in common. Okay, let's write this again over here. 2x plus 3. These are in common. We have 2x plus 3. And our other factor is 3x minus 5. Going back to our sample problem, we can multiply the 2 times 48, we'll get 96. Here we have the factors of 96. They need to subtract to give us 29. That would be right here. Those two subtract to give us 29. We need negative 29, so we need negative 32, positive 3. Now, after we've done that, we group these. And so we had our x to the 4th minus 16, and the other part. Difference of squares. Okay, the first and the last terms are perfect squares. And they will have a minus between them. They're difference. So it's going to have to be a subtraction problem. This one is not a difference of squares. It can be factored if there's a common factor, which there is, but this is not a difference of squares. Let's go up to this problem. A squared minus b squared. The a squared is a times a. B squared you would get from b times b. Now, difference of squares, you have to have different signs. The middle term always cancels out. We have a difference of squares. We want to make sure and bring the 3 down and bring this down, and then we're going to factor this. So I'm going to bring this over to this side so we can keep expanding on this part of it. Okay, we brought this over here. This is going to be factored into difference of squares. So there we go. So looking a little further, we see we still have a difference of squares. And nothing will factor anymore, so now we have our answer. Last thing, check by multiplying. You get what you started with. So it checks out. And we did it. And I would like to also thank Valerie Mirabal for helping me with the filming process.